In this video, we're going to be looking at how to do loops and iteration in Python. Now, in this video, I'm going to be focusing purely on while loops. I'm not going to introduce for loops yet. However, obviously, you can go on the internet and find about for loops fairly easily. Let's actually have a look at how loops might look like in a flowchart. So we start off with a variable, starting off with x equals 1. I then display 1 times 7, or x times 7, so which is going to be 7 obviously. I then add 1 to 7. If x is less than or equal to 12, which it is, it's going to come back to this line of code here. Okay, so it's going to output x times 7, which is going to be 2 times 7, so 14. Adds 1 to x, and it's going to keep going until x is 13. Now, as soon as x is 13, it's no longer less than 12, and it's not equal to 12 either. So then it will follow the no and end the program. So it's going to repeat this a number of times until this condition's met. So notice that it ends on an if statement in flowcharts. Okay, so when we draw things in loops in flowcharts, we'll always have that if statement. But when we come to programming it, we still have a look at what that code would look like in Python. Now, start off with x equals 1 like we did before, and then you can see we have the x equals x plus 1. We then have that print statement, and both of these need to be repeated each loop. Okay, so they're indented into the while loop like that. We then have the condition. I've just realised I made a slight mistake. That should be greater than or equal to. Never mind, my mistake there. But we've got a condition. This is when the while loop stops. So the way while loops work is it repeats whatever's inside it until this condition becomes false. Okay, so while that condition is true, the code inside will keep running. Now, there's a number of elements to a while loop. First of all, we've got initial value. This is where the loop is going to start. We're then going to have the end condition, so when the loop should stop. So initial value is where we're starting at. End condition is when it should stop, and it should be false to say it stopped. Then we're going to have code to repeat, and that's obviously this line of code. And then we must have a way of getting from this initial value to the end value, because if we didn't, we have what's known as the infinite loop. It would just loop forever. So that's why we've got this x equals x plus 1, because that will allow us to go one step at a time from 1 all the way over to 12. Now, while loops themselves and those basic ideas need practicing straight away. Okay, so go on to IS Codes and do some of the challenge 1 while loops. Okay, just get used to that little statement. Think about, okay, where's it starting, where's it ending, how do I get from the start to end? Now, in order to truly appreciate while loops, we need to start thinking in terms of problem solving. Okay, so consider the following program. So we want to write a program which will ask for a number, divide that number by 2, and display the number of times it divided, integer division, and the remainder. It will then take the integer part only and divide that. It will then keep going until 2 can no longer divide. Okay. So we're going to use two operations which you may not be familiar with. Integer division. Now, integer division is when it divides two numbers together and just gives you the rounded down version of it. So if I did, for example, 3 divided by 2, obviously that doesn't divide cleanly. Okay, so we'll go once. So if I did 3 integer division, 2 with the double slashes, that's just going to give me the number 1. Okay, so he rounds down the value. So when thinking about a while loop and trying to use one, we need to think about 4 key elements of it. Okay, what's my starting position? When does this loop start? How I'm going to end it? Okay, what condition do I need to end it? Bear in mind the loop will always run when it's true. How do I get from that start to end? And then finally, let's have a look at our thing. So what is the starting point? Already gathered, ask for a number is the starting point. So I'm going to ask for a number. Then our end point is when it's going to stop. So we're going to keep going until 2 no longer divides. A nice thing to think about is that word until. Okay, so when until I hit a condition. That's a nice way to think about when you're problem solving. That's what my condition is going to be looking like. How do we get from the start to end? It will then take the integer part only and divide that. Okay, so that's how I'm going to get from my start to the end. And finally, I've got the code that I'm going to repeat each time. So let's actually start to develop the code for this problem. Okay, so I need to ask for a number. Okay, and I've got a code pattern for that already because we've looked at that in the past. And here it is. So I ask for a number, I cast it into an integer, store it into a new variable, and I've called that variable number. Okay, so starting point is really straightforward. Nothing unusual. The end condition needs a little bit more thought though. Okay, so here's the end condition that I'm going to be using. Now the number will keep reducing by half, which means eventually we'll get 0. So if I divide a number by 2, it's going to get smaller. Okay, so what this problem is saying, so let's say I start off with a number, let's say the number is 14. Okay, if I divide 14 by 2, I'm going to get 7. If I divide 7 by 2, well, it doesn't divide cleanly, but if I do integer division, I'm going to get 3. If I use integer division again on that, I'm going to get 1. If I divide that again and use integer division, I'm going to get 0. Okay, so you can see I'm going from big number to small number. So every time I'm dividing by 2, I'm getting a slowly smaller number, which is what this is doing right here. So my end condition is I'm going to keep going until the number, well, is smaller than 0. Okay, so I've got greater than 0. Whenever we are going down, we're going to use greater than. If I'm going up, I'd use less than. Okay, because bear in mind this code will only run if it's true. So while number is greater than 0, I repeat the code. If I did use less than here, what will happen is, well, number less than 0? No, it wouldn't be, because it will be, say, 14. Let's say that's when I started. That would be false, so the code wouldn't run. So it's now worth having a go at some more while loop task. You've got a bit more information about it. So again, go through the challenge 1, 2, 3, and hopefully by now you can start attempting the challenge 3 task using a bit of problem solving. So what we've just looked at is the problem solving aspect with while loops. So maybe try to use those to help you solve the challenge 3. Let's have a look at another while loop. This example is using something called nesting. Now, nesting is when I have a block of code inside another block of code. Okay, so in this case, I've got an if statement which is inside a while loop. So notice the if statement is tabbed in, so it's inside the while loop, and also the code of this if statement is tabbed in once more. Okay, so I know that this line of code, line 8, belongs to the if statement because I've tabbed it in, and I know this if statement, line 7, belongs to the while loop because it's tabbed in. So let's actually read the code. So I've got head and tail count, so this is going to keep track of how many times I see a head or tail. Then I've got the variable I'm using to keep track of how many times the loop is running, called number of coin throws, and that starts at 0, so that's my initial value. I then got my condition to end the loop, so whilst it's less than 100, so while I haven't thrown 100 coins, keep going. I've got the code that I'm repeating, which is right here, and then I've got my way from guessing the start to end, which is here, number of coin throws plus equals 1. Okay, so it's going to run this inner bit of code 100 times. Once it's finished, it then runs these last 2 lines of code to basically say how many heads and how many tails it saw. So you can have if statements or while loops inside each other, and now you've seen how if statements can be placed inside a while loop, so hopefully armed with that knowledge, you'll be able to answer some of the other tasks in the while loop section. Okay, hopefully by now entering the challenge 3, the gold section, to be able to really use problem solving and start to apply together all of the knowledge you've gained so far.